Exercise 1A, question number 1. State a condition when a force produces 1. Translation motion, 2. Rotational motion. State the condition when a force produces, of course, on a body, okay, on a body. They're not mentioned, but on a body, okay. State the condition when a force produces translation motion and rotational motion. So naturally, here, for such answers, you should not try to use your own words a lot, okay? It should be like as short as possible. Answer the first part, okay? When a body is free to move, when a body is free to move, correct? When a body is free to move. Like, children, a ball is kept on a floor. It's free to move anywhere. You apply a force on the ball starts moving in the direction of the force. That is what, okay? So when a body is free to move. The second one, okay, produce a rotational motion. When is it? Okay, when a force produces a rotational motion in a body. When a body is pivoted at a point. When a body is pivoted at a point. Okay, when a body is pivoted at a point. Okay, now this is very interesting, beta. Now, of course, when a body is pivoted at a point, you apply force anywhere, it will not bring out rotational motion, beta. Yeah, of course, you have to select, okay, a suitable point in such a way that you apply a force at that point. It then rotates, correct? So this is, okay, first one is a condition needed for producing translation motion. And the second one is a condition needed for producing rotational motion. I hope everybody understood this question answer, okay? Define moment of force and state its SI unit. Define moment of force. Now, look here, children, what is moment of force? Okay, I'll tell you, moment of force is nothing but product of force, product of the magnitude of force, and the distance of the line of action of force from the axis of rotation. Correct? So, moment of force is defined as a product of magnitude of force, and perpendicular distance of the line of action of force, line of action of force magnitude of force and perpendicular distance of the line of action of force from the axis of rotation. But you should know this. This is a definition, okay? Then they wanted to tell the SI unit. See, usually both the questions are connected, okay? So moment of force is defined as a product of magnitude of force and perpendicular distance of the line of action of force from the axis of rotation. Now, but that is nothing but, I'll purposely say moment of force. In short, I'll just say is nothing but force into distance. Of course, this distance is nothing but perpendicular distance of a line of action of force from the axis of rotation. Now, I said it because SI unit, I can remember it from the formula. So, SI unit of moment of force is SI unit of moment of force is this formula. Force का क्या है? Meter SI unit. Okay, force का क्या है? Sorry, Newton, and Newton. Okay, and please keep in mind capital N. And what is this? Meter, Newton meter. You can always call it as Newton meter. Okay, children, very important, very easy. Okay, so one thing I'll remember it. The definition always like this. Moment of force is force into distance. इसको बोलते हैं बेटा moment of force. So, its definition, moment of force is defined as a product of magnitude of force and the perpendicular distance of the line of action of force from the axis of rotation. I hope people have understood me here. Okay, now question number 3. Before we moment of force, question number 3, is moment of force a scalar or vector? Okay, so moment of force is a moment of force is a vector quantity. Moment of force is a vector quantity. Moment of force is a vector quantity. Moment of force is what? A vector quantity. Learn it with me, children. Now go to question number 4. State two factors affecting the turning effect of a force. Okay, question number 4. State two factors affecting the turning effect of the force. This turning effect is nothing but moment of force. Turning effect is nothing but moment of force. So state two factors affecting the moment of force. Instead of saying turning effect of force, they get to use the moment of force. What moment of force? Affecting matlab mother. So naturally, you know the formula beta. The formula में जो दो quantities है, moment of force क्या है? Force into distance. So naturally, पहला the two factors, okay, affecting that is magnitude of force. What is it? Magnitude of force. Greater the magnitude of force, greater will be the turning effect. Greater will be the moment of force. And also, it depends upon distance of the line of action of force. Distance मतलब perpendicular distance. Perpendicular distance of line of action of force. Line of action of force from the axis. Action of force from axis of rotation. From axis of rotation. From axis of rotation. Okay. So remember the same formula helps you to remember this. The two factors affecting the turning effect. Turning effect दूसरा नाम है मोमेंट ऑफ फोर्स का, करेक्ट? या टर्निंग इफेक्ट का दूसरा नाम है मोमेंट ऑफ फोर्स. दैट मींस आई वांट टू फैक्टर्स अफेक्टिंग द मोमेंट ऑफ फोर्स. मोमेंट ऑफ फोर्स का फॉर्मूला क्या है? फोर्स इनटू डिस्टेंस. वही बराबर लिखो. So the two factors, okay, are magnitude of force and distance, perpendicular distance. Better use the word perpendicular distance of line of action of force from the axis of rotation. Now we go to question number 5. When does a body rotate? State one way to change the direction of rotation of a body. See the first question. When does a body rotate? Second, state one way to change the direction of rotation of a body. Then give a suitable example to explain your answer. Got it? So there are almost, when you see question, you understand properly, children. When does a body rotate? State one way to change the direction of rotation of a body. Give a suitable example to explain your answer. Simple. Okay, first one. When a force is when a force is applied at a suitable point, not at any point, one particular point, at a suitable point, when a force is applied at a suitable point on a body pivoted at a point, when a force is applied at a suitable point on a body pivoted at a point, then the body rotates, about an axis passing through point of axis passing through point of pivot. Passing through point of pivot. Okay, first part of the question. So when does a body rotate? So when a force is applied at a suitable point on a body pivoted at a point, then the body rotates about an axis passing to the point of pivot. Okay. Now, second part. State one way to change the direction of rotation. The direction of rotation of a body can be changed by changing the Direction of the force applied. Direction of force applied. Now, I want to explain this with the help of, okay, so I'll tell you. Like, you can see it. There's an axle passing through this hole, and this is you can say the handle of that axle. Okay, so naturally, please have a look at this. Is my figure A, got it? And the same, I'll draw one more diagram of the same. Okay, of the same. Okay, now you can see here the same axle I draw. The same axle I draw. This is the handle of the axle. Okay. Now you can see here this axis of rotation. Okay. Now this axle is connected to the axis of rotation. Okay. So when I apply a force in A and B, two different figures. When I apply a force on A, you can see a force on A. It will produce a anti-clockwise movement. And when I change the direction of force here downwards. Okay. So what will happen? It will bring out clockwise movement. Got it? So I can say the question is give a suitable example to explain your answer. So an axle, when an axle is rotated, you can see here, okay, when a force is applied on an axle and it brings out an anti-clockwise movement. Now when the force is applied on the same axle in the opposite direction, force is applied on the same axle in the opposite direction, you can see it will bring out clockwise movement. Okay, that means by changing the direction of the force, body can be made to rotate anti-clockwise and clockwise. Okay, see, I can tell you this like this, children. When a force is, you can see here, example. I'm trying to explain it with the help of an example. They wanted to give an example, okay? So a circular disc can be rotated, a circular disc as in figure A is rotated anti-clockwise by the force exerted on its handle, Okay. Now, on the same handle, a circular disc, as in figure A, is rotated anti-clockwise by the force exerted on the handle. Now, the same disc as shown in figure B, will rotate clockwise See, a circular disc as in figure A is rotated anti-clockwise by the force exerted on its handle. The same disc as shown in figure B will rotate clockwise when the same force is exerted on the handle in the opposite direction, in the opposite direction. Okay. Direction of rotation of body can be changed by changing the direction of force applied. Example, a circular disc. A circular disc, as in figure A, is rotated anti-clockwise by the force exerted on its handle. The same disc, as shown in figure B, will rotate clockwise. Will rotate now clockwise, where clockwise when the force exerted on the handle in the opposite direction. Okay, I just trying to say, children. Question number 6. Write an expression calculating moment of force about a given point. So what is the answer? Beta simple. The formula, what I told you, moment of force equal force into perpendicular distance of line of action of force, from axis of rotation, axis of rotation. Okay. Then we can see here, beta. We go to the next question now. Question number 7. State one way to reduce the moment of given force about a given axis of rotation. State one way to reduce the moment of a given force. मतलब force is given. Force का हम लोग कुछ नहीं कर सकते हैं. Force तो given है. लेकिन moment of force को कम करना है about an axis of rotation. So here, children, use a common sense. What is the formula, beta? Formula for moment of force is force into perpendicular distance. Okay, perpendicular distance of axis of rotation, perpendicular distance of the line of action from the axis of rotation. So naturally, children, the force is given already. So naturally, distance has to be reduced so that the moment of force can reduce. So naturally, what should be the answer? State one way to reduce the moment of given force about a given axis of rotation. Got it? I'll just write by one way, okay? By reducing the perpendicular distance of the line of action of force, from the axis of rotation, I hope you understood this. Very simple, okay? Question number 8. State one way to increase the moment of given force about the given axis of rotation. So state one way to increase the moment of a given force. Force is given already. Force it cannot increase. Okay, force is there, constant, about a given axis of rotation. So naturally, it's just opposite of this question. By increasing the answer will be by increasing the perpendicular distance, of the line of action of force from the axis of rotation. So this question is just an opposite of your question number 7. Okay, just an opposite of your question number 7. Okay, what do you understand? Question number 9. What do you understand by the clockwise and anti-clockwise movement of forces? When is it positive? What do you understand by the clockwise and anti-clockwise movement of forces? When is it positive? So simple, children. See here, If the force turns a body, okay, if a force turns a body in clockwise direction, got it? Then the moment of force is said to be anti-clockwise moment of force. And if the force turns a body in anti-clockwise direction, then the moment of force is said to be anti-clockwise moment of force. Okay, so listen, if the force turns a body, if a force turns the body in a clockwise direction, in a clockwise direction, then the moment of force, is said to be clockwise movement of force, movement of force. If the force turns the body in a anti-clockwise direction, then the moment of force is said to be anti-clockwise movement, okay? Movement of force is said to be anti-clockwise movement. Now the question is, last part, when is it positive? The moment of force is positive when it is anti-clockwise. The moment of force is positive when it is anti-clockwise, okay children, keep it in your mind. Okay, so naturally clockwise रहेगा तो negative रहता है, लेकिन इधर खाली पूछा है when is it positive. So moment of force is positive when it is anti-clockwise moment of force, okay children. Now we go to the next question. Question number 10. Why is it easier to open a door? It's easier to open a door. Why is it easier to open a door? By applying a force at the free end of it. You find it easier to open a door by applying the force at the free end of it. Now, what is the meaning? Why? The question is why? Why is it? Got it? So remember, children, by applying a force at the free end of the door, by applying a force at the free end of the door, please here, by applying a force at the free end of the door, Oh, I'm so sorry, beta. I'm so sorry. I mean, it should have been right, but I better write like this. The free end of the door, is at maximum distance from the axis of rotation of the door. Axis of rotation on the door. Hence, a smaller force is enough to bring the bring the necessary movement of force for closing or opening of a door, for closing or opening of a door. Okay, hence it is easier to open a door, hence it is easier to open a door by applying the force at the free end of the door. Okay, so once again I'll read it. The free end of the door is at maximum distance from the axis of rotation of the door. And the smaller force is enough to bring the necessary moment of force for closing or opening of the door. Hence, it is easier to open a door by applying the force at the free end of the door. A very simple and apt answer. Okay, children. Now we go to question number 11 of it. Now, question number 11. The stone. Question number 11. The stone of the hand flow grinder is provided to the handle near its rim. Give a reason. The stone of the hand flow grinder is provided with the handle near its rim. So the handle near its rim is at a maximum distance from the axis of rotation. Hence, a smaller force exerted on the handle can produce enough of the moment of force for the stone to rotate. Are you getting me here? And that's the reason. Okay. So remember, so it's easier to grind. Okay. So you can see the same way, children. The handle near the rim of the grinder stone is at maximum distance from the axis of rotation, Hence, a smaller force applied to the handle can bring out the necessary moment of force The handle near the rim of the grinder stone is at maximum distance near the rim from the axis. Hence, smaller force applied to the handle can bring out the necessary moment of force, okay, required for grinding, okay. So you can see, children, we go to the next question. Question 12. It is easier to turn the steering wheel of the larger diameter than that of the smaller diameter. Give reason. Understand the question. It is easier to turn the steering wheel of the larger diameter than that of the smaller diameter. Give reason. Means you've got two steering wheels. एक बड़ा diameter का, एक छोटा diameter का. It's easier to turn the steering wheel of the larger diameter than that of the smaller diameter. So simple, beta. The force on the steering wheel is always applied always applied at its rim. At its rim. Okay, the force on the steering wheel is always applied at its rim. And hence, in a hence the force, force exerted on the steering wheel, of larger diameter is at larger distance, is at larger distance from the axis of rotation, axis of rotation. Hence, the force needed, the force of the steering wheel is always applied on the rim. Hence, the force exerted on the steering wheel, the force exerted on the steering wheel of larger diameter is larger distance from the axis of rotation. Hence, a smaller force, is needed to bring out the necessary moment of force. Whereas the force applied on the steering wheel of smaller diameter is at smaller distance from axis of rotation. Hence, a larger force is needed to bring out a same moment of force. Hence, it is easier to turn the steering wheel of larger diameter than that of the smaller diameter. The force on the steering wheel is always applied at its rim. The force exerted on the steering wheel of larger diameter is at larger distance from the axis of rotation, and smaller force is needed to bring out the necessary force. Whereas the force applied on the steering wheel of the smaller diameter is smaller distance from the axis of rotation, hence a larger force is needed to bring out the same moment of force. Hence it is easier to turn the steering wheel of larger diameter than the smaller diameter. Question number 13. Okay. Here. A spanner or wrench has a longer handle. You know, spanner or wrench is used to either remove the nut, loosen the nut from the wheels, or tighten the nuts on the wheel. Everybody knows it. So naturally, a spanner has a longer handle. Why? So that a smaller force applied on the longer handle can bring out the necessary moment of force to turn the nuts. Are you getting me? It's up to you. Okay. But it will become easier. It becomes easier. Okay. So I just said it. Now come to question number 14. Question number 14. A, B, and C are three forces. You can see force A, force B, force C. You can see A, B, and C are three forces. Okay. Force A, force B, and force C. Each of magnitude 4 Newton. All these three forces are 4 Newton forces. Okay. As shown in the figure. The point lies in the same plane. Now, which force has the least moment of force about two? A moment of force is nothing but product of the force and the perpendicular distance. So naturally, सबका force magnitude तो 4 ही है, तो सबसे कम distance में C है. Got it? तो 4 into 0.6, 2.4 सबसे कम रहेगा, बाकी दोनों का बड़ा रहेगा. So question is, which force has the least moment about two? Force C has a least movement about O. Okay. Give reason. Since it is at the smallest distance from O. Since it is at smaller distance from O. Next, second one. Okay, what I can see. Which force has the greatest moment about it? See, force. Har force, magnitude of each force is 4. 4 into 0.9 is 3.6 Newton meter. 4 into 0.8 is 3.2 Newton meter. And this is 2.4 Newton meter. So naturally, which has maximum moment? Force A. Got it? So which force has the greatest moment? Force A has a greatest moment. Force A has a greatest moment. Okay, about O. Greatest moment about O. Since, give reason again. Okay, since it is at farthest distance, farthest, F-A-R-T-H-E-S-T, farthest distance from, O. Okay, and now let's see a third one. Which force has, okay, name the forces producing clockwise and anti-clockwise. You can see here, forces A and B produce a clockwise movement, and forces A and B will produce clockwise movement, whereas force C will produce anti-clockwise movement. Okay. Now the name okay, either. Now fourth one, what they are saying, what is the resultant torque about point 2? So see, A and B will produce clockwise movement. So I'll say total clockwise movement is equal to since clockwise should be taken as negative. Okay, we know that. So minus 4 into 0.9 plus minus 4 into 0.8. So what will happen, beta? Minus 3.6 minus 3.2. So it is becoming minus 6.8 Newton meter. Now, total clockwise movement. Now, total anti-clockwise movement equal total anti-clockwise movement equal anti-clockwise movement. Now look here, ये clockwise movement negative लेने का, इसके लिए हमने minus लिया है. Now total anti-clockwise movement equal 4 into what is the distance? 0.6. That is 2.4 Newton meter. अभी they want the resultant torque about मतलब total torque, total moment of force. Moment of force, other name for moment of force is torque. Torque बोल के टेंशन नहीं लेने का. Torque का मतलब क्या है? Moment of force. तो मैं ये क्वेश्चन रब करता हूँ बेटा साइड में. See, the T part is, the fourth part is, I want the total resultant moment of force. So what will happen? Resultant moment of force equal, 1 minute children, let me rub it off, okay? Doesn't matter, it will take a little time, but it should be easy for you to understand when you're studying, okay? So what will happen here? Therefore, total or resultant torque, therefore resultant torque equal दोनों को ऐड करने का बेटा, बट ये नेगेटिव है, -6.8 न्यूटन मीटर plus 2.4 Newton meter. So how much you get? Minus plus. So naturally answer minus is a bigger number. Plus वाला smaller number है. तो दोनों का subtract करो 6.8 minus 2.4 will be 3.4 4.4 4.4 लेकिन minus 4.4 Newton meter. Got it? But minus tells us that it is a clockwise moment of force. Therefore, resultant torque is 4.4 Newton meter clockwise. I hope people understood me here. Okay. Okay. Now, we go to the next sum. Adjacent diagram shows a heavy roller, this is a heavy roller with an axle passing through O, which is to be raised on the pavement XY. Okay, this roller has to be raised on the pavement XY by applying a minimum force. You have to apply a minimum force. Okay, show by an arrow on the diagram the point of application and the direction of force should be. So you can see here, A is a point of application of force and F is a force to be applied. Okay, I have shown by an arrow here. Okay, children, we go to the next question now. A body, question number 16. A body is acted upon by two forces, each of magnitude F. Both are equal in magnitude. That is what it means. Okay, but in opposite direction. Both these forces are in opposite direction. State the effects of the forces. What these two forces will bring the effect. Okay, if both forces act at the same point of the body, if both forces are in opposite direction, or if they're acting at the same point on the body, but in opposite direction, both are acting at that same point from the opposite directions. So both the forces will cancel each other. So result both these forces, since both are equal in magnitude, opposite in direction, since I will say, okay, since both the forces are equal in magnitude, opposite in direction, act at the same point on a body, Hence, they cancel each other, resultant force will be zero, resultant force will be zero, no motion is produced on the body. Got it? Now the B part, when you look at it, the two forces act at two different points of the body at a separation of r. That means this is, suppose, please have a look here. The earlier case you could have thought like this, but suppose this is a body, this is a point, this body force is acting like this force is acting like this, and naturally both are equal in magnitude, opposite in direction, act at the same point, so they cancel each other. So the resultant force acting on the body will be zero. But now what? The body, please here, both this, like this is acting here, this is acting here at a separation of r. So both are in opposite direction, equal in magnitude. So the both will produce a rotational motion. Both will produce a rotational motion, okay, about the midpoint, okay, about the midpoint of this, okay, about the midpoint of the distance between the two forces, okay. So you can see what I'll say. Since both the forces are equal in magnitude, opposite direction, act at, since both the forces, since both the forces, both the forces are of equal magnitude, opposite in direction, in direction, both the forces are equal in magnitude, opposite in direction, okay, at two different points, separated by a distance r, will produce a rotational motion in a body about an axis passing through the midpoint of the distance, between two forces, okay, children. See, both the forces are of equal magnitude, opposite direction, act at two different points separately at a distance r. Okay, it will produce a rotational motion in a body about an axis passing to the midpoint of the distance between two forces. Got it? Now, after this, we go to the question number 17. Draw a neat label diagram to show the direction of the two forces acting on a body to produce rotation. Matlab, two forces are acting on a body and it produces rotation. So you have to draw a diagram for it and also mark the point about which the rotation will take place. So naturally, just now some answer of the last question, okay? Suppose this is a body, okay? And what I do, the two forces act. Here is one force acting at this, okay? And another force is acting here. Got it? So when I show you the forces here, you can see here, this force is acting in this direction. This force is acting in this direction. This is clockwise. This is anti-clockwise, and this is also clockwise. Both of them, but the directions are different. Both of them bring the same clockwise movement, okay? And both will rotate. This will rotate about the midpoint O. So you can see, draw a neat label diagram to show the direction of the two forces. Okay, direction of the two forces acting on a body to produce a rotation on it at point O, about which the also mark the point about which the rotation takes place. So I hope people have understood this. Okay, see, these are two forces. This force acts at point A, this force acts at point B. Look at the direction of the forces. They are opposite. They are opposite, but both of them will bring out the same, what you can say, movement of force. Both will bring a clockwise movement of force. So naturally, this body will rotate and about this point. Oh, got it? Okay, I hope people understood the diagram. Now I go to the next question. What do you understand by the term couple? State the effect. Give two examples of couple action in our daily life. What do you understand by the term couple? State the effect. Give two examples of couple action in our daily life. So simple, beta. Here you can see these two equal and opposite forces. Two equal and opposite forces acting at two distinct points, separated by a distance, two equal and opposite forces acting at two distinct points separated by a distance, and the line of action of the forces, are parallel, then the forces are called couple force. Okay, two equal and opposite forces acting at two distinct points separated by a distance, and the line of action of the forces are parallel, then the forces are called couple force. Now state the effect. They bring out the two forces bring out a turning effect in a body, turning effect on the body. Okay, I wrote, and I'll give two examples in a daily life. Now, just not two examples, Veda. Please see examples in a daily life. Okay, like examples from our daily life. Like one, opening of a tap. Okay, you have to apply a couple force. Okay, and the second one, okay, like the second one can be, like, you can call it as the key, opening of the key, opening a lock with the help of key, with the help of key. Opening a lock with the help of a key. Okay, that key you insert inside, you apply a couple force on the key to open the lock. Okay, so you can see this answer, children. We go to the next question. Moment of couple. Define moment of couple. Question number 19. Define moment of couple. Write its SI unit. Okay. So moment of couple is the product of is defined as moment of couple is defined as product of either force into either force and the arm of the couple and the arm of the couple. Now, this arm of the couple is nothing but distance between the forces, okay? The distance between the forces is called couple force, okay? Arm of the couple, okay? So, moment of couple is defined as product of either force and the arm of the couple. Now, SI unit of moment of SI unit of moment of couple will be is what it will be better product of either force. Force is Newton into arm the couple is meter. Newton, meter. Okay. Then I go to the next question. Question number 20. See, prove that movement of couple equal force into couple arm. This is question number 20. Prove that movement of couple equal force into couple arm. So you can see here, suppose there's a bar AB and pivoted at O, pivoted at O, pivoted at O. Now at A and B, two forces F are acting. So that is what I'm writing here. Consider a bar AB pivoted at point O, at point O. Two equal and opposite forces, two equal and opposite forces F are acting at point A and B respectively as shown in the figure. Consider a bar AB pivoted at point 2. Two equal and opposite forces F are acting at point A and B respectively as shown in the figure. Okay. So what is now first one? Moment of force F. Moment of force F. Moment of force F. Moment of force due to force at A. Moment of force due to the force at A. Force at A. Got it? Now you can see here, beta. This is nothing but a clockwise movement. Okay? Due to force at A equal F into, I can say, OA. Okay, clockwise movement. Clockwise movement of force due to the force at A. Clockwise movement of force. Clockwise movement of force due to the force at B is equal to F into OB. Therefore, total moment of force is equal to, since both are clockwise, F into OA. F into since both are clockwise movement of force due to force at F into A, clockwise movement of force due to force at B, F into OB. So F into OA, total movement of force, F into OA plus F into OB. I know I have to take it as negative, but I'm not taking. Makes no difference. Okay. So what will happen here? What is common here? F is common. OA plus OB. So what you see, F into AB. What do you get? F into AB. So total moment of force equal, that is clockwise. Okay, clockwise equal F into AB. So you can see here, this AB is nothing but a couple arm. AB is the couple arm. AB is the couple arm. Therefore, I can show it to you here, but AB is the couple arm. Therefore, total movement of force, total movement of force, total movement of force is equal to F into couple arm. AB is the couple arm. Okay. Therefore, movement of couple equal movement of couple equal. I can also call this as movement of couple equal force into couple arm. Couple arm. Got it? That AB is a couple arm, F is a force, either force. Okay. So you can see here, children, I can say movement of couple, I proved it as either force into couple arm. Okay. We go to the next question. Question number. What do you mean by equilibrium of a body? Question number 21. See, when a number of forces, number of forces are acting on a body, and the number of forces are acting on a body. When number of forces are acting on a body and it doesn't produce, and there is no change in its state of rest or state of linear motion or rotational motion, then the body is said to be in equilibrium, then the body is said to be in equilibrium. See, when a number of forces are acting on a body and there is no change, in its state of rest or state of linear motion or rotational motion, then the body is said to be in equilibrium. Got it? Please understand this. Okay, when a number of forces are acting, you will see the forces are acting, but still there is no change in the state of rest. The body is at rest, it tends to remain at rest, or in a state of linear motion along a straight line, or a rotational motion. Then you see the body is said to be in equilibrium. Okay, children? State a condition for a body acted upon by several forces to be in equilibrium. Conditions for a body, then more than one condition. See, when a force is acted on a body tends to remain at a rest. That means when the body will remain at rest, or suppose it is in linear motion, it will remain in linear motion. Naturally, when first condition, I'll tell you, the resultant force acting on the body is zero. Secondly, second condition. See, say the condition for a body acted upon by several forces to be in equilibrium. See, equilibrium is the state of rest or state of linear motion or rotational motion. So rotational motion is brought about by the movement of forces. So the resultant movement of force about a point is 0. So this should be the true condition. The above resultant forces acting on a body is 0. So because of this, either the body is in a state of rest or state of linear motion. And because of the second condition, got it? Resultant movement of forces above the point is 0. Because of it, it doesn't produce any rotational motion in the body, even though the forces are acting. So we say the body is in equilibrium. Okay. So these are the two conditions. Okay, children. Now we go to question number 23. State a condition when a body is in static equilibrium. You again state a condition when a body is in dynamic equilibrium. Then you have to give one example of each. Okay, you have to give one example of each, static and dynamic. So simple, children. See, when several forces are acting on a body and the body maintains a state of rest. See, we say the body is in static equilibrium. That means what is the condition needed for static equilibrium? The body should remain in a state of rest. The body should remain in a state of rest under the influence of several forces. This is a condition. The body should remain, first one, static. The body should remain in a state of rest under the influence of several forces. Okay, for static equilibrium, I better say for static equilibrium. For what is this? This is for static equilibrium. This is a condition required for static equilibrium. One, for static equilibrium. For static equilibrium. For static equilibrium. Okay. What is that? You can see for static equilibrium, the body should remain in a state of rest under the influence of several forces. In the same way, acha, iske example. Okay, one example we can give of our own. Okay, a book kept on a table. A book kept on a table. On a table is in a state of, is having a static equilibrium. A book on a table is having a static equilibrium because its weight is acting on the table in downward direction and the table exerts an equal and opposite normal reaction force on the book. The book on a table is having a static equilibrium because its weight is acting on the table in a downward direction and the table exerts an equal and opposite normal reaction force on the book in the upward direction. Hence, these two forces are acting on the book and the book remains in a state of rest. So you can clearly see why it's static. See, I told you in the beginning, a book on a table is having a static equilibrium because its weight is acting on a table in a downward direction. And the table exerts an equal and opposite normal reaction force on the book in the upward direction. Hence, these two forces are acting on a book and the book remains in a state of rest. Correct? So naturally, why it is having a static equilibrium, I hope people understood. Then for what is the next one? Dynamic equilibrium. For dynamic equilibrium. For dynamic equilibrium, there is no place, children, but anyhow, I'll try to squeeze in here. Okay, you can see here, children. I'll put it like this. For okay, so now you can see here, children. I'll write it here. Okay. For dynamic equilibrium, the body maintain its state of motion, either linear or rotational, in spite of several forces acting on it. For dynamic equilibrium, the body should maintain its state of motion, linear or rotational, in spite of several forces acting on the body. Example, now here, for this example, you can see here a planet revolving around the sun is having a dynamic equilibrium, because in spite of centripetal force acting on it, a planet revolving around the sun is having a dynamic in spite of centripetal force acting on it towards the central sun. Still the planet continues to move. Okay. Now I go to the next question, children. State the principle of movements. Give one device as application of it. Okay. According to principle of movements, a body remains in equilibrium if the sum total of anti-clockwise movement, clockwise movements is equal to sum total of clockwise movement. Okay. Now the question is, children, give one device as application of it. Answer, like one device, okay, which is an one device that can be said due to an application, hey, now one device, so sorry, I just framed a wrong sentence, okay. I'll change it with a, okay, one device that works on this. The one device that works on principle of movements is a physical balance, used to measure weights, okay, used to measure weights. Okay, children, now we can see, we go to next question, question number 20. Describe a simple experiment to verify the principle of movements. You know what is principle of movements? Na? Anti-clockwise movement equal clockwise movement. Now, if you are supplied with a meter rule, a fulcrum, and two springs with slotted weights. So what I do, suspend a meter rule horizontally from a fixed support. You can see this is a fixed support. This is a fixed support by a strong thread. Okay, you're suspending this meter rule horizontally from a fixed support by means of a strong thread. Suspend two spring balances with slotted weights. Got it? With slotted weights, W and W2, with slotted weights. Okay, with slotted weights, W1 and W2 on either side of O. Okay, now adjust the distances of the spring balance in such a way that the scale remains in horizontal, that is equilibrium position. You keep on adjusting. See, एक साइड में ज्यादा हो गया तो क्या होगा, टिल्ट हो जाएगा उधर, तो उसको तो अभी एडजस्ट करो इधर डिस्टेंस, ताकि एक ऐसा टाइम आए कि पूरा स्केल हॉरिजॉन्टल रहे. जब हॉरिजॉन्टल रहेगा, that time find the product of W1 and L1. Find the product of W2 and L2, and what you see, when it is in equilibrium, W1 into L1 equal W2 into L2. That is, principle of movement is verified. Okay, children? That means we did the first exercise. Okay, we'll do the next exercise next time. Till then, see you all. Bye, children.